All right, today we're going to do the 2.3 quadratic graphs vertex format. F of x equals ax squared plus bx plus c. And we said this was standard format. And we gave you a function that was in standard format. We said something like y equals x squared plus 3x plus 2. And we decided that we wanted to learn some things about this quadratic. Where is the vertex? Where is the axis of symmetry? Where are the y-intercept, or where is the y-intercept? And where are the x-intercepts? With this problem, we were able to FOIL it. And so you said, well, this becomes x plus 2 and x plus 1, and you set it equal to 0 to find the x-intercepts. So this is what we're doing here. And then you'd say x equals -2 and -1. But then we tweak the problem. We tweak the problem so that way instead of a 2, maybe we put a 5 here. And then you're kind of like, uh-oh, I can't FOIL this. And we came up with an idea of rewriting this. And we said, well, if you could rewrite it in this format, a times x minus h squared plus k equals 0, then you could figure out what those x-intercepts are by solving for x. And we said you could do it in 3 moves. Move number 1 was subtract k from both sides. Number 2 was divide both sides by a. Oh, actually 4 steps, sorry. Number 3 was square root. And then step number 4 was add h. So basically, you solve this equation for the variable x by moving everything over to the other side, and you can figure it out. Okay, so that's sort of where we left you off last week. And we said that this format was called vertex format. And the reason this is called vertex format is because you actually get the vertex when you convert it into this. And the vertex is going to be, and we'll go back over here, h comma k. H from here and k from here. We talked about that being the opposite of b over 2a. And then the y-intercept is when x equals 0, and the x-intercept is when y equals 0. So we'll say y equals x squared plus 3x plus 5. And let's solve it. Let's put it into vertex format. And so the technique we used is something called completing the square. And this is the idea. We're going to set y equal to 0. So we'll say x squared plus 3x plus blank plus 5 minus blank equals 0. And in this blank we're going to put, I just call this smiley face because I don't really want to put a variable in there, because sometimes putting variables in can be confusing. But we're going to add something to the left side of the equation, and then we're going to subtract the same something from the left side of the equation. So it's a zero sum, right? You add something, you subtract it on the same side. It doesn't change it. So what are we going to add and subtract from both sides? Smiley face is equal to the middle term divided by 2 squared. So that's what we have to add and subtract to the left-hand side. So that's going to be 3 divided by 2 squared, which is 9/2. And the 3 comes from right here. That's b. So now we're going to take 9/2 and we're going to add it, and then we're going to subtract it. So we're going to say plus 9/2 and minus 9/2. And believe it or not, this guy right here is a perfect square. It becomes x plus 3/2 times x plus 3/2, which is x plus 3/2 squared. It may take you a while to figure out, well, what are factors of 9/4 that when you multiply them together give you 9/4, and when you add them together give you a 3? It could be tough to figure that out. But what you could do is this guy right here, this number here, this 3/2. Remember when we took b and divided it by 2 and then squared it? Well, if you stop before squaring, that number actually is the number that goes into this format. This part right here is just along for the ride. And so we're going to change this into, maybe we'll say 20/4 minus 9/4. And so that'll be plus 11/4. So we'll move up here, and we get x plus 3/2 squared plus 11/4 equals 0. So from here, you could tell me what the vertex is. H is going to be negative 3/2, and K is going to be 11/4. Continue on and solve this equation. So we'll get x plus 3/2 squared equals negative 11/4. X plus 3/2 equals the square root of negative 11/4. So x equals negative 3/2 plus or minus the square root of negative 11 over 2. This is a quadratic in standard format. And up to this point, what we would do is we would give you an example with numbers for A, B, and C, and we'd say complete the square, and you'd complete the square, and we'd figure out a bunch of stuff about it. Now what we're going to do is we're going to leave the variables in the equation. This will help us find the x-intercepts. And what I want you to do, what we're going to do right now, is we're going to run complete the square on this thing, leaving the variables in. The first thing we need to do, by the way, is divide everything by A. So that's going to leave us with x squared plus b over ax plus c over a equals 0. So now we're going to do this. X squared plus b over ax plus blank plus c over a minus blank equals 0. What goes in the blank is your middle term, which is this guy. Divide by 2 and square. So when we divide this by 2, we're going to get b over 2a, and then we need to square that, which is going to give us b squared over 4a squared. And that's what goes in each one of these. And now, believe it or not, this first half is a perfect square. It's going to be x plus something times x plus something, which is going to be x plus something squared. What is the something? Say it again. B over 2a. And can I ask how you got b over 2a? Right, because we talked about how if you're not sure, right, like if you're not exactly sure how to figure this out, then you take this little detour and you look at the number inside the parentheses before you squared it, which was b over 2a. So this becomes b over 2a squared. And now we've got to figure out the second half over here. What does this become? And those look like two fractions. I've got c over a, and then I also have negative b squared over 4a squared. And those are two fractions. In order to add fractions, I need a common denominator, right? And so I need to multiply that c over a by something. So I'll multiply by 4 over 4. And I need another a because this is a squared. So I'm going to multiply by 4a. So if I do a rewrite on this, this is going to become 4ac divided by 4a squared minus b squared over 4a squared. And then I can put that all together under one denominator, and I'll get 4ac minus b squared all over 4a squared equals 0. So again, all we're doing is completing the square on a generic formula. In order to solve this, to figure out where our x-intercepts are, we need to solve that for x. I got to kick all that junk over to the right-hand side and get x by itself. And then we'll be good to go. Then we'll have the intercepts. So I think we'll start by subtracting this 4ac b squared, blah, blah, all this garbage. So let's subtract this. So we're going to get x plus b over 2a squared equals, if I kick this whole thing over here, I'll get negative 4ac plus b squared over 4a squared. And I really don't like having the negative on that 4a squared, so I'm going to reverse, I'll swap the order of this and just say b squared minus 4ac all over 4a squared. That looks a little bit better, so I don't have that negative as the lead. We'll just reverse the order of that. Okay, and then the next move is square root everything. So now we have x plus b over 2a equals the square root of b squared minus 4ac, all divided by 2a. Because remember, I can take the square root of this guy, and that's just 2a. So I'll put that in there. And then our last move is kick that b over 2a over to the other side, or subtract it from both sides. So we'll get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all divided by 2a. Does that look like anything you've seen before? Quadratic formula. What does it give you? The x-intercepts. This guy here, opposite of b over 2a, it's your axis of symmetry. That's exactly what that is. So I'll put this one right here. Here's your axis of symmetry. So remember that list of things that we wanted to find out? Axis of symmetry, that is equal to the opposite of b over 2a. What's the next thing we want to find out? I don't know, how about the vertex? Well, the vertex is going to be the opposite of b over 2a, comma, f of the opposite of b over 2a. Remember that this is x equals the opposite of b over 2a. And somewhere on here is your vertex that has coordinates x, opposite of b over 2a, and y, f of opposite of b over 2a. Where are the x-intercepts? Well, your first x-intercept is going to be, again, off this line of symmetry right here. That distance is going to be plus the square root of b squared minus 4ac over 2a. It's going to be the plus. And this distance from here to here is going to be the minus. This will be the minus square root b squared minus 4ac all over 2a. So embedded within the quadratic formula are your line of symmetry, opposite of b over 2a, and the distance from the line of symmetry that your two x-intercepts land on the graph. So there's one x-intercept here, and there's another one here. We'll call this x sub l, the left hand, and x sub r, the right hand x-intercepts. This whole entire process started with taking a generic quadratic way up here, f of x equals ax squared plus bx plus c, and all we did is we applied the process of completing the square. Divide both sides by a, put in your blank, and figure out what smiley face is, and then do a little bit of algebra. Oh, okay, a lot of algebra. And then out pops the quadratic formula. But it's not enough just to memorize the quadratic formula. You have to be able to interpret it and understand, what does the graph mean? So the opposite of b over 2a is your axis of symmetry. It's the yellow line right down the middle here. Plus root blah, blah, blah is the green segment, and minus root blah, blah, blah is the purple segment going the other way.